Hello everyone, welcome to Unify Chemistry Study channel. So as we are discussing about the questions related to magnetochemistry chapter, so the next question of this particular chapter is the complex that shows orbital contribution to the spin magnetic moment is copper hexaaqua complex, nickel hexaaqua complex, cobalt hexaaqua complex and chromium hexaaqua complex. So before discussing the answer of these particular questions, I want to say something about orbital contribution in octahedral complex. So in octahedral complex, there are 6 ligands arranged around a central metal ion in a symmetrical manner. The metal ion typically has d orbitals that can hybridized with the ligand orbitals to form molecular orbitals. The resulting molecular orbitals can then be occupied by electrons, and the arrangement of these electrons can determine various properties of the complex. In terms of orbital contribution, the 6 ligands in an octahedral complex can be categorized as either strong field or weak field ligand. So strong field ligands such as cyanide or carbon monoxide cause greater splitting of the d orbitals and lead to a larger energy difference between the lower energy d orbitals, that is T2g state, and the higher energy d orbital of the Eg state. So as you can see, so this is the higher energy Eg state and this is the lower energy T2g state of octahedral complex. On the other hand, weak field ligands such as water or other ligand cause smaller splitting of the d orbitals and a smaller energy difference between T2g and Eg orbitals. The occupation of these molecular orbitals by electrons determines the magnetic and electronic properties of the complex. In particular, the number of electrons in the T2g and Eg orbitals determines the complex magnetic moment and the way it interacts with the external magnetic field. The arrangement of electrons in the Eg orbitals can also determine the complex color and its ability to undergo certain type of reactions such as electron transfer or ligand substitutions. So therefore, the orbital contribution in an octahedral complex depends on the nature of the ligands and the occupation of the molecular orbitals by electrons. So this particular information can be used to understand and predict various properties of the complex as well as its reactivity and behavior in different chemical environment. Now to solve this problem, you can see all these complexes are octahedral and the coordinating ligand here is water molecule. So therefore, if we talk about the first complex, that is copper, you can see the oxidation state is 2 plus, so it is 3d9 electronic system. On the other hand, the second complex, that is nickel, also the oxidation state is +2 and it is 3d8 electronic system. Cobalt 2 plus, third complex, again it is 3d7 electronic system. On the other hand, the last complex, that is chromium 2 plus, it is 3d4 electronic system. Now if you try to find out their electronic distribution, so for the first complex, what will be the electronic distribution? It is T2Z6 Ez3. For next complex nickel, it is T2Z6 Ez2. For third complex, it is T2Z5 Ez2, and the last one, it is T2Z3 Ez1. Now the right option of this particular questions is option number C is the right option, because this particular complex shows orbital contribution to the magnetic moment via spin orbit coupling. Okay, so the right answer of this particular question is option B. Thank you very much for watching.